Hello, thank you for joining us today on this webinar in a midsummer webinar. And we have a brand new exciting API to introduce. We've been working on it for a couple of years now, and it's finally ready to reach maturity where it's actually a full release. And this is our C++ API. My name is John Tkaczewski. I'm the president and co-founder of Unlimitech Software, the makers of FileCatalyst products. And we've been doing file transfers pretty much since very beginning, since year 2000. And in 2007, we introduced FileCatalyst, file transfer acceleration product line. And we've been doing this since very beginning, since very inception of this company. So the C++ API has been around for a couple of years now. It first was started as a project for downloads only, so you were able to do UDP acceleration just for downloads. We then moved on to building uploads. Really, just this year we finished up this. And then we also added congestion control and all the more advanced features as well. So we feel now this is actually a product ready for to be used and embedded by our clients into their own applications. Today's webinar, I'm really going to be concentrating on the Windows platform using Visual Studio 2013. But this C++ package is available for many other platforms, which I will get into in a second. So what features are available in C++ in the current build of C++? Well, you have acceleration for both uploads and downloads, for UDP and TCP. TCP can also be done with multi-threading. So that means if you start multiple TCP threads, you'll get faster improvements. And this will help you with those stubborn firewalls that block UDP. You can also bring TCP down to a single stream, and then it will really behave more like a regular FTP interface. MD5 checksum, this will give you your guaranteed delivery. So after you transfer the files, you can do a bit-by-bit comparison of what was sent and generate like an electronic digital delivery of the file. Bandwidth and congestion control. So you can set your bandwidth, the exact rate, and also you can have the client to play nicely on the network if other applications require to use the network. We will slow down and give other TCP applications a chance to work when you enable congestion control. We'll give you also SSL and AES encryption, so you can use this over a public environment where you have a public network and you require encryption. The resuming is also built in, so you have the ability to automatically set the number of retries and resume the transfers. And so let's say I'm sending a 5 gig file, it breaks at 2 gigs, the API will automatically wait X number of seconds and resume the transfer from the last successful attempt. You can also resume files that you're currently already sent previously, you just want to resume it. You can send single or multiple files. Multiple files are being sent via a vector, and a single file is just a path to the file. And then you can also do recursive folder level transfers. So if you have a large directory structure, several directories deep, you can just point it to a folder and the API will take care of it. So what's missing in our C++ API? We don't provide currently the auto zip and unzip features, as well as we don't provide zip chunking. So if you have, imagine you have a problem of 1,000 of little files, images, or XML files, you want to send them, you can zip them up in a one big chunk and send them over the network. This will speed things up quite a bit, because then it takes, instead of waiting this long to open a socket to transfer one file, you're just sending all these files zipped up. When the files are really small, sometimes it takes longer to open up a socket to send than the actual file transfer part. What else is not available is multi-client transfer. So with our Java API, if you point it to a folder and you set it to, let's say, 4 worker threads, 4 files will be going all at once. You can define priorities of I want the largest files first, I want the smallest first. So the multi-client allows you to specify simultaneously what to transfer. The C++ API only transfers 1 file at a time. Deltas or rsync. So imagine you send a file and then a few days later you have a new version of it. With C++, you'll have to retransmit the whole file and overwrite it. In Java, you have the ability to have an rsync built in. And progressive transfers. So imagine your tail FTP, or you're transferring a growing file. So a file that is still locked on the operating system, and you're kind of just chasing the end of the file and transferring it. So these options are not available in C++. We will eventually build them out as well, but for all purposes of most of our clients, these advanced features are not something that are not showstoppers. So you can easily do still your UDP transfers right within C++, and this C++ code will not require any Java. What kind of speeds did we get with this? We got our official line that I'm supposed to tell everyone is that we right now support 1 gigabit transfers with the C++ API. However, we have a number of anecdotal history on this, where our testers have seen speeds much better than a gigabit in harsh network conditions, even up to 10 gigs. I think us in the upcoming releases of this C++ API will be optimizing it and certifying it for the top speed. I think it shouldn't be hard to get us to 10 gigabits with this product, because even currently our testers saw the unofficial results were showing us 2, 3, 5 gigabit speeds fairly easily. So this is something, stay tuned for this. This will be improved, but I think you can easily deploy this for any 1 gigabit or even maybe 2 gigabit applications if you have to. So what's required? Well, first of all, the C++ API, it's native API, it's only C, so you have different builds for different versions, not Java here anymore. So we'll provide you a Windows 32 and 64-bit. We'll provide you a Linux 32 and 64-bit. We'll also provide you a Linux ARM 32 build. So for all those fans of Raspberry Pi that want to maybe transfer files from a Raspberry Pi to FileCatalyst server, now you can do it with the ARM 32 build. And as well, we provide you an OS X, Mac OS X build to provide you ability to transfer files within your Mac OS X applications. Down the road, I think we will do a Mac OS webinar as well on how to code with FileCatalyst on Mac OS X. But this webinar today really pertains onto Visual Studio. What else is required? Visual Studio 2013 on Windows. On Mac, you will need GCC or Clang. On Linux as well, you can use Clang or GCC. On Windows only, you also require a Boost library. So you'll have to go to Boost and download version 158. You cannot go older or newer. It must be 158 when you're building the Windows. OpenSSL, it's something we package with our C++ API, and again on Windows this is included. On Mac and Linux this is not a problem. It should just work for you out of the box. And of course you need a FileCatalyst Direct server with a connection license flag, so that allows you to accept connections from APIs on the server. So before I get started, I'll show you a demo. I just want to show you a few prerequisites, what I've done. So I've installed my FileCatalyst Direct server. I did set the API license for it under Advanced Server License to API. You can see here a screenshot. I downloaded Boost. I'm running this on Windows, so I must download this version of Boost, 158. I got the 64-bit. If you're on 32-bit Windows, then you'll need the 32-bit, but for Windows you have to get that. And I downloaded also our FileCatalyst C++ API from our download site. The download site is password protected. You'll have to contact your FileCatalyst representative to get the password. And this comes in the form of an executable installer. And once you're running the installer, I made a quick note here that you have to, when you're presented with the option to add FCPP to system path, you must click that. Otherwise, this is not gonna, the builds are not gonna work for you. So without any further delay, let's get into the actual code here, and let's see what we can do. So what I've built here, I'm starting here with a very basic C++ application running in Microsoft Visual Studio. This application right now is not linked to FileCatalyst. There's no linkage, whatever. It's a very simple one. It also has only a one button and a text area. So if I click and I run this right now, this is the type of thing I get. Nothing is linked, nothing works. I'm going to now link these to my FileCatalyst API examples. But you can see that's what it does. So the first thing I have to do is that the FileCatalyst API comes with only release versions. So if you do want to run this in debug mode, you would have to point it to your own Boost debug version. The Boost debug version is very large, I think a couple of hundred megs, which you would have to download and link it. In this example here, I'm just going to be showing you how you can run it in the release mode. That means you can still step through your application, but you cannot step through the Boost libraries. Really, that's what it means. So I'm going to flip this over to a release. And in here, I'm going to have to add, because I'm running on 64-bit, I'm going to have to add a 64-bit platform here. Okay, and close. So now I flipped my project to a release 64-bit. Because I did that, Visual Studio now won't remember my settings. So I will have to change these settings to change these settings to so they pick up on the release side. So I have to right click, properties here, and I just have a couple of changes to do on the linker side here for my application to work. First one is my entry point. I had that specified on the debug side, but now I'm running on release side, so I have to re-specify this one more time. And under system, I have to specify what subsystem I'm running. And I'm running here Windows subsystem, so I just have to apply that as well. So now if I run this again, I'm just going to be able, I want to make sure I still can compile everything and run. There we go, we're still good. Okay, so now let's get into actually linking the FileCatalyst C++ API. So I'm going to first go and add my headers. So I'm going to go to VC++ directories, and under my include directories, I'm going to be adding the libraries to FileCatalyst API. So I'll go to program files. So by the way, FileCatalyst API installs by default in program files, FCPP, and include FCPP. So this takes care of my include files for this. Now I also have to include the boost. I also have to provide the boost includes. So I'm just going to do the same thing. The boost includes by default boost installs by default into local boost. So I just have to select the boost main folder here. Now libraries. Libraries are here, because we already packaged the libraries needed for Boost, I just need to link it to the libraries that come with FileCatalyst C++ API. So I'm going to, again, to Program Files, FCPP, lib. That's about as much as I need to do on the VC++ directories. On the linker, I also have a few things to change. I have to go to additional linker input, and I have to add additional dependencies here. I already prepared them here, so you don't watch me type these 4 file names. But what these are the Boost library, some Boost libraries, and the SSL libraries. Once again, this is something very specific to Visual Studio. You will not have to do this on all the systems, but on Visual Studio you will have to make these changes. So libby is SSL, SSLE is also for SSL, and then my 2 Boost libraries that I need. And now if I click OK, let's see if we can still build this. Clean, rebuild, and we're still good. We're still building. So that's all what I have to do from project setting wise. Now I'm gonna go into the code here and actually enter my code. So I just click on view code here. This brings me into the code of this thing, of my application. As you can see, here's my click action for my button. And this is where I'm going to have it tell to do transfers. But before I do this, I have to actually grab my method. So working from the examples, which I will show you in a few minutes, I already prepared my method, which I will go over with you in just a second. So I added this method, example upload, and now this example upload here, I'm just going to call it from here, from my onClick for the FileCatalyst. As you can see, all my FC things are still red because I have to also include, do an include for this. So if I go to the top of my, as you can see here, include is FC Windows HPP. So once again, the include will be slightly different on Linux and Mac, but this is what I need on for the Visual Studio side. So by including this, this will give me, this will clean up all these red things that you saw here. So now if I run this application, so now I'm running this application. As you can see, I tied my button to the to FileCatalyst server. These are the settings I'm sending. So I'm sending on their user, password is 12345, server IP is this, local file, and I'm sending these files. I'll get into details in a minute. I just want to show you how this would work. So now I'm going to open my FileCatalyst server interface here and view logs, just so I can show you the logs here. There we go. So here are my logs. I'm going to clear this here. And now if I press this button, hopefully transfer will happen. And there's my transfer. You can see the t.zip file that I specified as being sent. And if I look at the system monitor here, you can see the transfer happening, and it's just finished right now. So you can see it was pretty quick, but the transfer is complete. You can see I sent that t.zip, and it was roughly 83 megs or 84 megs in size. So let's go in my code here. Let's go through it quickly, see what I changed here. So I took really I'll show you in examples in a minute. There's 6 examples we're shipping it. I think I used example number 3 to build this. But you can get this, and then I slightly modified it. So what did I do here? First of all, I set my local file path. For options, I had to use the server name. Then I set up here the mode. See, I'm using UDP. So this is something you have to set up from the FC object. Set override. So this means that every time I transfer, it will overwrite the file and transfer it again. If I don't set this, then the file transfer would not happen because it will see that the file already exists and skip it and show you that transfer was successful, yet number of bytes sent was 0 because there is nothing to send. Your bandwidth is in BPS, so it's in bauds. So this number is roughly 100. This number is 100 megabits. So this is my bandwidth I set up. I set up my congestion control, so I can manage the speed. If another application comes in, wants to use bandwidth, it will slow down. And then I did here another interesting trick that I wanted to show you here is to bring in C++ strings into .NET, because my text box 1 is a .NET interface. And my strings coming back from FileCatalyst C++ API or C++, I have to, every time I get a string from the API, I have to do this trick, gc new string, and then pass c.str to cast it to a C string. And then my text box will take this information. So then I started putting a message that I'm uploading. I'm starting the upload here with the FileCatalyst API, and then at the end I'm printing statistics. And you can see here FTP get more recent file stats. So this is the information you saw at the end when I was transferring. And once again, I had to do that GCNU string, and then I had to do C string after whatever comes from the API. All the exception is via try and a catch block. You have an FC exception type. FC exception, as I will show you in the documentation, gives you a lot of information of what went wrong and how to get information from it. So that's really the entire demo I wanted to show you for the coding side. Let's just I wanted to go through some of the documentation here and review with you some documentation. So when you install FileCatalyst API, it installs a group called FC++ API, and here you have your link to examples, for example, and as well you have a link to documentation. So the documentation is very well written. It comes with a command line that was already pre-built for Windows and for Linux. So you don't need to use C++. You can just use the command line if you want. And this one is a native C++ API. You can pass different arguments to it. You can, do auto-resuming, and you have a translation here what the switch on the on the command line versus what is the switch on the corresponding C++ API. You can specify your SSL, you can specify your number of threads, whether you're doing FTP or TCP, whether you're sending a single file or folder level, and whether you want to verify MD5 at the end. There's some API information that you can only do with an API. You cannot do it through command line, but these are much more advanced information that you can, for a programmer, this might be needed. It also shows you the speed, how it's reported here, and the formatting of the speed transfers. On Windows here, as I mentioned, the include will be fcwindows.hpp, or you can do it this way if you want to just do FileCatalyst.hpp. This would be system-wide, would work across all the platforms, but you would have to define FC Windows. This one will do just Windows. There will be also we'll also provide you a tutorial how to actually get this project working and what to include and where once this is all released online. Example codes, I will get that into a minute, but if you go to namespaces list FC, here you have a list of all the members for FC and what they do. Same way, if you go to namespace members, you can have all your functions, type definitions, enumerations, and so on. If you look at the class list, you have also your classes, including here somewhere you were talking about exceptions. And here's your exception list. As I mentioned, everything is with a try and a catch block, and you can get different exception with a timestamp, the reply code from the server, and the message from the server. So it's very easy to track your messages and errors. So to look at some examples here, as I mentioned, we have several examples that we package. Here's one for downloads. So this will download. You can see how a sample code, how to print and different information from the downloads. It gives you, it displays all of this in command line here. These examples are all written for command line, so they might have to change them if you're running in a window environment. Example 2 is just another way of transferring files. Once again, there's a number of ways of doing it, and here you can see much more detailed statistics of what's coming from your object when you're transferring files. The example 3, I think, is the one I used for uploads. It's the simplest one. It just uploads. I just set a few more options for UDP and bandwidth, but the rest I left it intact. Example number 4, this gives you threading and shows you an example how you could do a transfer in a different thread. Once again, all of this is thread safe, so you can send a transfer to a background, and still obtain information of the transfer if you want. So this is another example that you get. And all these examples are really there for you to see different possibilities and options how to set up a transfer, send it either in the background, set it in the foreground. You can how to get statistics. They're there for you to really help you with the installation. So just last piece of information, how I got started with this empty C++ project that just had a button and a text area. I went to uh, this website here, BOGO to BOGO, where I followed their tutorial on how to setting up the simplest C++ application in Visual Studio. And then I just created the buttons, and with you here, I actually connected these buttons to do something. So there's a link for this. Once again, this will be all also posted for you along with my project. So thank you very much for attending, and see you next time. Bye bye.